In this lesson, one button press will resolve one complete, two-sided battle turn. Bell whispers first because it is faster. Bramblebud answers with friendly nudge. Both resolve bars update. The log preserves the action order. Every move button locks, and return becomes the only valid next action. This is episode 9 of Glimmer Grove, but it is also a standalone Godot lesson about deterministic rules, state machines, snapshots, and testable user interfaces. The finished Chapter 9 project is linked below. We are deliberately resolving exactly one turn. We are not looping until someone wins. We are not adding random accuracy, critical hits, rewards, retry, or animation delays. Those features create more states, and more states make a new rule harder to inspect. A narrow stop lets us calculate the expected numbers by hand, compare them with the game, and reject a second click. Once this one turn is trustworthy, episode 10 can safely build a complete battle loop around it. Series viewers should copy the Chapter 8 checkpoint named Glimmer Grove 08 BattleScreen. Standalone viewers can download the completed Chapter 9 recovery project and rebuild the lesson in a separate copy. Use Godot 4.7.1 stable, the compatibility renderer, and an 1150 2x648 viewport if you want the same paths and screenshots. The architecture works elsewhere, but exact node names and test values may differ in another project. Close Godot before copying the project. In File Explorer, duplicate your Chapter 8 folder. Rename the new folder glimmergrove_ch09_1_turn. Open project.godot from that new folder. Keep Chapter 8 untouched. If a script stops importing or your result differs from the hand calculation, the earlier checkpoint remains a clean comparison instead of becoming another unknown. Run the copied project before editing. Choose any starter, speak to Rook, and open the exhibition. Both creatures should begin at full resolve. The move buttons should be visible but disabled. Return should close the screen and restore the village. If any of that is already broken, restore Chapter 8 now. We want every new failure in this lesson to belong to the controller work, not to an older scene or content problem. We need only 3 new terms. A phase is one named stage of the battle. Deterministic behavior gives the same result from the same starting data and choice. A snapshot is a detached package of values prepared for the screen. The controller owns phases and rules. BattleScreen receives snapshots and fills controls. This means the screen never reaches into controller variables, and the controller never searches for labels or progress bars. Follow the arrows. Authored resources describe creatures, moves, and the encounter. BattleController creates runtime creatures and applies rules. It emits a snapshot whenever presentation should refresh. BattleScreen converts that snapshot into names, bars, buttons, and log text. When the player chooses a move, the screen sends only the selected index to the controller. Data does not know the interface. The interface does not calculate damage. Main does not become a pile of battle branches. In the file system doc, expand scripts, then data, and double-click CreatureInstance.gd. Put 2 small methods beneath the existing healing method. Is defeated returns true when the species is missing or current resolve is 0. Take damage clamps the requested amount to at least 0. Subtracts it. Clamps current resolve at 0, and returns the applied amount. Damage belongs to a runtime creature instance. Never subtract health from the shared creature species resource. Type this bounded block exactly. Maxi prevents negative input from healing a creature and prevents a large hit from displaying negative resolve. The return value gives future effects a reliable record of what was applied. Save the file and let Godot finish parsing before continuing. If red errors appear, compare the indentation, colons, arrow return types, and the spelling of current_health. In the file system doc, right-click script/battle and choose Create New, then Script. Set the file name to BattleController.gd, choose the empty template and create it. The script extends ref counted because it represents rules and state, not a node in the scene tree. Give it the class name BattleController. We can construct a fresh controller for each exhibition without adding invisible rule nodes to main. Add explicit preloads for the 4 custom types this controller uses. Each path starts with res:// and points to the real script file. These constants make the dependency visible and avoid relying on the editor's global class cache import order. If Godot says it cannot preload a path, use the file system doc to compare every folder and underscore. Do not replace a missing path with an untyped variable. Add a phase enum with ready, player input, resolving, and turn complete. An enum gives readable names to integer states. Ready means no valid battle is accepting input. Player input means one move may be selected. Resolving means the controller is applying ordered actions. Turn complete means this chapter has reached its deliberate stop. These names make illegal transitions easier to reject than a collection of unrelated booleans. Declare a state change signal that carries one dictionary snapshot. Then declare phase, definition, player companion, opponent companion, turn count, and an array of log strings. Notice what is absent. No button, label, scene path, or canvas layer. The controller owns battle state. BattleScreen owns controls. The signal is the boundary between them. Before typing code, write the rule in plain language. Guard reduction is the integer part of 40% of the defender's base guard. Raw damage is move power plus attacker power minus that reduction. Multiply the full raw value by the affinity multiplier. Round the product, and apply a minimum of 1. The order matters. Converting to an integer too early can change the answer. A rule that can be calculated on paper is easier to balance and test. Add a static calculate damage function with typed attacker, defender, and move parameters. Return 0 when any required resource is missing. Build raw damage over several lines so each part can be inspected. Ask affinity multiplier for the bonus. Finally, return max of 1 and the rounded product converted to an integer. Static means the test can verify this pure calculation without first creating a controller instance. Add affinity multiplier as another static function. Grove resonates against Tide. Tide resonates against Ember. Ember resonates against Grove. Each favorable match returns 1.25. Everything else returns 1.0. Neutral never receives a bonus. This is a small original cycle, not a borrowed chart. Keep IDs lowercase and compare string names with the ampersand string syntax shown on screen. Create start with a creature instance and battle definition parameter. Reject a missing companion, missing species, missing battle data, or missing opponent species. Store the valid inputs. Heal the player's active companion. Create a fresh creature instance from the opponent's species resource. Reset turn count and the log. Set phase to player input. Emit the first snapshot and return true. A new runtime bell wisp means the shared bell wisp resource never loses health. BattleScreen will connect to state change before calling start. That order matters. Start emits the initial snapshot containing full resolve, the available moves, and player input phase. The screen uses it to enable the buttons and focus the first choice. If you call start before connecting the signal, the first update disappears. The battle may exist internally while the interface still looks like Chapter 8. Begin choose move with strict rejection. If phase is not player input, return false. Reject a negative index and any index beyond the player's move array. Read the opponent's move array and reject an empty list. These checks happen before phase changes or damage. They protect the controller from double clicks, stale UI events, bad indexes, and incomplete opponent data. A disabled button is helpful, but the rule owner must still defend its own boundary. Read the player's selected move and bell wisp's first authored move. Then set phase to resolving. Compare base speed once. Use greater than or equal so the player wins a speed tie. We are not sorting labels or delaying animations to suggest an order. The controller makes one explicit decision from data. Later, opponent decision logic can replace index 0 without changing the screen. If the player is faster, apply the player's move first. Only let the opponent answer if it is still standing. Otherwise, apply the opponent move first and let the player answer only if it remains standing. This structure guarantees at most 2 actions. The defeated check sits between them, where it owns a real rule. Even though our known route cannot defeat either creature in one hit, preserving the boundary now avoids an impossible response later. After the ordered actions, set turn count to 1 and phase to turn complete. Append a clear log line saying this lesson stops after 1 turn. Emit 1 final snapshot and return true. Do not return to player input yet. A second call now reaches the phase guard and returns false. That deliberate stop is both a teaching boundary and a regression test. Add a private apply move helper. Ask calculate damage for the number. Tell the defender instance to take that damage. Read the multiplier only to decide whether the log should add. The affinities resonated. Then append 1 player facing sentence with creature name, move name, and damage. This helper coordinates existing rules. It does not know whose turn it is and does not touch the interface. Snapshot returns a dictionary of presentation, safe values, phase, turn, names, current and maximum resolve, fallback colors, opponent trainer, move descriptions, and a duplicate of the log. Do not put buttons, labels, scene paths, or the controller itself into this package. The screen should be able to rebuild its entire display from the snapshot without reaching back into battle state. Create an array of dictionaries. If the player companion and species exist, loop through available moves. For each move data resource, append only the display name, description, affinity converted to a string, and power. This conversion is intentional. The presenter receives values it may display, not a resource it could accidentally mutate. When you add another visual field later, add it to the snapshot contract and test it. Now open scene/ui/battlescreen.tscn. Then open its attached battle_screen.gd. We are replacing Chapter 8's direct data fill with a controller instance. Keep the existing typed on ready node paths. We are changing how values arrive, not rebuilding the scene. Add a preload for BattleController and a typed controller variable near the top. In ready, loop over the ordered move button array. Connect each pressed signal to choose move and bind that button's index. Bind stores the index with a callback, so button 0 sends 0 and button 1 sends 1. Keep the existing return connection. Hide retry, return, and the whole screen initially. Signals should connect once when the scene becomes ready, not every time a battle opens. In present, store and validate the active companion and definition. Make the screen visible. Construct a new battle controller. Connect its state change signal to refresh. Then call start with the companion and battle data. This order guarantees the first snapshot has a listener and that visible controls can receive focus. A fresh controller also prevents state from a previous exhibition leaking into the next one. The screen's choose move function should be almost boring. If the controller exists, forward the index. Do not calculate speed, affinity, damage, or turn order here. The button reports what the player chose. The controller decides what that choice means. This one-line boundary is the main architectural lesson of the episode. Refresh receives 1 dictionary. Read each name and fallback color. For each creature, clamp maximum resolve to at least 1. Read current resolve. Assign both progress bar X value and value, then build the text label. Setting only value is a common mistake. The bar may use an old maximum and show the wrong proportion even while the number looks correct. The controller should never know a progress bar exists. Read the moves array from the snapshot. Loop over the 4 existing button slots. If the index is beyond the move list, hide that button and continue. Otherwise, show it. Fill the display name, capitalized affinity, power, and tooltip description. The screen is rebuilding presentation from one package. It is not reading the companion resource directly anymore. Read phase from the snapshot and compare it with player input. Disable every move button whenever that comparison is false. When waiting for input and the first button is visible, grab focus on it. Show return only in turn complete and move focus there when it appears. The interface reflects controller state instead of inventing its own boolean. Both layers guard double activation, the screen disables the button, and the controller rejects the phase. Before testing, calculate the known route. BellWisp speed 5 is greater than BrambleBud speed 4, so BellWisp acts first. BellChime has power 7. Add BellWisp's base power 4. BrambleBud guard is 6, 40% is 2.4, and converting that reduction to an integer gives 2. 11 minus 2 equals 9. Neutral has no multiplier. BrambleBud begins at 34 and must end at 25. Friendly Nudge has power 6. Add BrambleBud's base power 4. BellWisp guard is 4, 40% is 1.6, and the integer reduction is 1. 10 minus 1 equals 9. Again, neutral has no bonus. BellWisp begins at 28 and must end at 19. Write these expectations down before running the test. A test is strongest when it confirms a prediction instead of defining the answer after the code runs. Right-click the test folder and create validate_1_turn.gd with scene tree as its base type and the empty template. This test can run headlessly without opening the game window. Preload content catalog, CreatureInstance, and BattleController. In init, reload content, request BrambleBud and the Hearth exhibition, create the runtime companion and controller, then start the battle. Assert that the first valid move returns true. Assert turn count 1 and turn complete phase. Assert BrambleBud resolve 25 and BellWisp resolve 19. Call choose move again and fail if it returns true. Finally, check Ember to Grove equals 1.25 and neutral to Grove equals 1.0. These assertions cover order, arithmetic, the stop condition, and both affinity paths without depending on pixels. Save all scripts. In the file system doc, right-click res:// and choose Open in File Manager. Click the address bar, type PowerShell, and press Enter. Copy the full path to your Godot console executable. Run the command shown on screen with your paths. The expected result is pass, speed order, damage, affinity, log, and 1 turn stop or deterministic. If the exit code is not 0, fix the first reported owner before opening the game. Run the project, choose BrambleBud, and begin Rook's exhibition. Confirm 34 and 28 before acting. Activate friendly nudge once. The log must list BellWisp first, then BrambleBud. Resolve must show 25 of 34 and 19 of 28. Both move buttons must be disabled. Return must be visible and retry hidden. This visual check catches layout, focus, and bar problems that a headless test cannot see. Try to activate a move again. Click it, press Enter, and press Space. Nothing should change. The screen disables the controls, but imagine a stale signal or a direct controller call bypassing the interface. Choose Move also rejects every phase except player input. This is defense at the actual rule boundary, not duplicated battle logic. Return to the village, restart, and choose Lantern Kip. Its speed 7 is greater than BellWisp's 5, so Lantern Kip must act first. You are not adding a Lantern Kip branch. You are proving the same comparison responds to different resource data. If the log still puts BellWisp first, inspect base speed values and the greater than or equal expression in the controller. If order is wrong, compare base speed and the player first expression. If numbers change but bars do not, set both max value and value from each snapshot. If another turn resolves, confirm the controller begins with a phase rejection and ends in turn complete. If damage is off by 1, check exactly where int and round occur. Do not change expected numbers until you can explain a deliberate formula change on paper. Stop the game, save every scene and script, and close Godot. Preserve the folder as Glimmergrove, ch091 turn. Reopen a copy, run the content, first companion, and 1 turn validators. Then repeat the BrambleBud play check. The verified recovery zip and its SHA-256 hash are linked below. Standalone viewers can use it as the complete reference implementation for every path and test in this lesson. The transferable Godot pattern is larger than combat. A user interface emits intent. A controller validates the current phase and applies one deterministic transition. The controller emits detached presentation data. The screen refreshes controls from that package. A focus test verifies numbers and illegal transitions without rendering. The same shape works for crafting, dialogue choices, card turns, puzzles, shops, and quest rewards. In episode 10, we will replace the one-turn stop with a complete loop. Player input will return while both companions are standing. Victory and defeat will become explicit phases. Retry, healing, and return will each receive a tested route. We will keep the same control or screen boundary built today, so the new behavior extends the design instead of rewriting it. Keep this Chapter 9 checkpoint untouched. It is the cleanest place to diagnose any future battle regression.